Hey 8th graders, after checking out some of your quizzes on math, I wanted to give you a few notes to see if we could improve some of those quiz scores. Talking about matter. Well, first of all, you need to know, what is it? Matter is anything that has mass and takes up space. People, like you and I, we certainly have mass and we take up space. Same as the soil we walk on, the air that we breathe, the water we drink and bathe in, and the computer I'm working on right now. All of these things have mass and they take up space, so they qualify as matter. Things that don't fit into the matter category, you can hear my voice right now, but sound does not qualify as matter. Same thing for light. I can see light, but it doesn't have mass and it doesn't take up space, so I can't consider it matter. Same thing with thoughts. I often say that my head is full of thoughts, but in actuality, thoughts aren't anything you can hold in your hand. Okay? They don't take up space, they don't have mass, so they don't qualify as matter. The next thing you all were being asked about on your quiz were elements. An element is a substance that cannot be broken down or separated into a simpler substance by chemical means. Okay, this is a periodic table and it lists all of the elements that we know of right now. It starts as number 1, hydrogen, goes all the way down to number 118, and I can't even pronounce that right hand. But an element is a substance that cannot be broken down into simpler substances. For example, my wedding ring is made of gold, which is down here at number 79 AU. If I cut my ring into pieces and I kept cutting it into smaller pieces, each time I got smaller, each piece would still be gold until eventually I got down to 1 atom, if that was possible, to keep cutting my ring down until I just had 1 atom left. That atom would still have all the properties of gold. But if I tried to cut that atom down any smaller, make it smaller than it is right now, then it would no longer have the properties of gold. Okay? So that's what we mean when we say an element is as simple as a substance can get. Okay? Cannot be separated or broken down into simpler substances and still have the same characteristics. Okay? Again, this is the periodic table, and it's the recipe guide for everything in the known universe. All matter is made up of one or more of the following elements. For example, if you take hydrogen up here at number 1, take 2 of those atoms, and you combine it with one of the oxygens over here at number 8, you get water, H2O. 2 hydrogen atoms, 1 oxygen atom. What do you say is an atom? Okay. An atom is the smallest unit of an element that maintains the properties of that element. Going back to my ring again, if I kept cutting my ring into ever smaller pieces, eventually I would get down to an atom. Okay? And that atom would still be gold, but if I went any smaller, it would cease to be gold. It would be something else. Okay? So an atom, the smallest unit of an element that maintains the properties of that element. Atoms are made of 3 things: protons, which have a positive charge; neutrons, which have neutral charge or no charge; and electrons, which have a negative charge. Now the protons and neutrons are found in the middle, what we call the nucleus, and the electrons orbit around the nucleus. Okay? Again, all the atoms in an element would have the same number of protons and neutrons. Okay? For example, all hydrogen atoms have 1 proton and 1 electron. Okay? What's the difference between an element and a compound? All the atoms in an element are exactly the same. So if I have some carbon, which is an element, has the symbol of C, all the atoms in it are exactly the same. Iron, which has the symbol Fe, is an element, and all the atoms in the iron look exactly the same. Okay? All the atoms in an element have the same number of protons, electrons, and neutrons. Now there are a few exceptions to that, but we'll talk about those at another time. Compounds, on the other hand, compounds contain two or more elements. An example would be sodium chloride. Sodium is an element all by itself. Chlorine is an element all by itself. But when we combine them, we get sodium chloride, which is a compound. Its symbol is NaCl. It's also known as table salt. The elements in a compound are held together by chemical bonds. Those bonds are either ionic or covalent bonds. An ionic bond is when an atom gives an electron to the other element that it's being bound to. And a covalent bond is where both of those elements share an electron. We'll talk more about that later as well. Molecules. The smallest unit of a substance that keeps all the physical and chemical properties of that substance. It can consist of one atom or two or more atoms from the same or different elements, bound together. That sounds a little complicated, but with a little practice it's not that hard at all. For example, oxygen. It's an element. But oxygen atoms don't exist in nature all by themselves. They don't like to be alone. So a molecule of oxygen is O2, simply two atoms of oxygen. Iron oxide, you and I know it as rust, is a compound. Okay? It compounds, puts together oxygen and iron. And a molecule of it looks like Fe2O3, which simply means two iron atoms combined with three oxygen atoms. A molecule of sucrose, that's the table sugar that you put in your sweet tea. It's also a compound of carbon, hydrogen, and oxygen. It's simply written C12H22O11. It contains 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. So in this slide we've taken care of two of the things that you have to worry about on your quiz. What is a molecule, and how do you read a chemical formula?
Good morning. I'm going to talk mixtures here for just a minute. The first mixture I have here is my snack food that I eat while I'm grading your papers. And this is an example of a heterogeneous mixture. Hetero, the prefix hetero, means different. And when you look at this snack food, you can see that it's a mixture of walnuts, cranberries, raisins, and blueberries. Okay? They're all mixed together, hence the mixture. And they're all different, which makes it a heterogeneous mixture. Okay? The second mixture I have here is a glass of sugar water. Now I stirred in a teaspoon of sugar to this, so it's obviously a mixture, and you can taste it and know that it's sweet. But when you look at it, no matter which angle you look at it, it looks exactly the same. You can't tell where the sugar ends and the water begins, or the water begins and the sugar ends. It looks exactly the same. Hence, this is also a mixture, but it is a homogeneous mixture. The prefix homo means same all the way through. So here, homogeneous mixture, dissolved, the same all the way through. Heterogeneous mixture, mixed, but I can easily see the different parts through it. There's a clear difference between where the cranberry is and where the walnut is. Different, hetero, same, homo. Hope that clears that out.